So now we're going to move on to learning how to write a unit test. So what we're going to do is just do a quick install in this video, and we're also going to walk through the Karma configuration. So to actually get this running, if we jump into our package.json, we're going to have a look through a few things that we actually need to get these running. We have a types Jasmine. We also have the Karma, which will give us the type definitions for both of those. We're going to be using Jasmine and Karma for running our tests. Jasmine is the syntax that we'll be using, and Karma is in fact the test runner. We also have the actual dependencies themselves. So here we've got Karma, the Chrome launcher, because we want to launch our tests in Chrome. We've also got Karma Jasmine, the source map loader, and the spec reporter. And we've also got Karma Webpack. Now, putting these together, because they are just dependencies, we actually have this Karma configuration. Now, inside this Karma configuration, we're exporting a module here with our configuration, which basically sets up our Karma test runner. So in my particular Karma configuration, we have a browsers property, which says we're going to boot up our tests in Chrome. You can, however, use something like Phantom.js if you're using something like a CI server, or you want to run your tests in a headless browser. We also have this array of files, which are necessary for actually running our unit tests. Things like the reflect polyfill, and we also have various zone files which allow us to write the tests. Now the interesting piece is where we have this pattern where we want to look for the .spec files only. So what we're going to be creating are these .spec.ts files, which will actually hold the logic for our unit tests. The other nice few things that we have here, our source maps are going to be created for our test files for debugging. And we're also going to use the reporter of spec. Now, when we actually run these tests in the terminal, we can see them nicely laid out with things like green ticks or red crosses for things that pass or fail. So now that we've actually walked through this, all I need to do is boot up my terminal. Now, to install the dependencies, we're just going to run a yarn install. If you're not using yarn, because we have an npm package, you can just run an npm install instead. So depending on your setup, you may wish to run an npm install or a yarn install. So this is all finished now. So what we can actually do to run the tests, we can say yarn and then test. Now the way that I have configured this in the package.json is I've added a scripts and then test, which simply just runs Karma start. So this is essentially equivalent to running Karma start. However, we're just running it as yarn test just to keep things simple. So in this lesson, we have just set up our testing environment. In the next few videos, what we're going to do is look through how to test various different pieces of an Angular app. So let's go ahead and start learning how to write a unit test for a pipe. Now we've covered pipes already, and I've actually taken the pipe that we created earlier on in this course, our file size pipe, which then transforms a byte into megabytes, and we can also add an extension. So this piece of code should feel pretty familiar, and we're simply going to write a unit test for it. Now what I'm going to do is create a new file. So we're going to create file size.pipe.spec.ts. Now these are spec files because our Karma configuration is actually looking for our spec files when it's running our tests. So it will only pick out our spec files to run our tests against. Now a typical unit test starts with a describe block, and we're going to create a file size pipe. Everything inside of here will just live inside this function. So what we want to do inside of here is it should convert the bytes to megabytes. This is also just a function. We can also check a few things as well. So we can say that the next test is going to check whether we are using our default extension. So we're going to say it should use the default extension when not supplied. And our third test is it should override the extension when supplied. Okay, so at the moment we have our testing set up in terms of what we actually want to test. We should test if it actually parses things to megabytes, checks the extension, and we can also override the extension. Now, before we can actually get going with this, we need to go ahead and import our file size pipe. So we can import that file size pipe from the current directory and file size pipe. And what we can do inside the describe block is actually create a new instance of that pipe. So we'll do const pipe equals the new file size pipe. And that's all we need to do to actually instantiate our particular pipe. So inside our first it block, what we're going to do is use an expect. So expect, you can see here it says jasmine.matches. So this expect function is actually provided to us via Jasmine. So what we actually want to test is the pipe, and you can see we have this transform method, so we can just simply call that. Now what we're going to do is just pass in some numbers. So we'll do 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we can say that we expect this value to be 117.74 megabytes. And what we can do is simply duplicate this, and we can just change this number. So we'll do 987654321. And we can then test that this actually is 941.90. So what we can do is save this out. And what I'm going to do is just open my terminal, and we're going to run this yarn test. So what we'll actually see when this loads is we'll see that we have 3 tests passing, because these 2 it functions will actually pass even though we have nothing inside them. So we could actually comment them out and just confirm that our single test is actually passing. Now at the moment we're not actually using much of Angular because a pipe is really easy to test on its own. What we call these are isolate tests because we're not using the Angular framework directly, because we haven't actually configured anything inside this particular test file. So it's really nice and easy to actually test our pipes. So what we'll do is quickly wrap this in a describe block, because in the next video, we're going to create what we call a shallow test, and we'll actually do these below so we get some nice indentation inside the terminal. So we can neaten these up, and if I close the terminal, you can see that we have a describe block on the higher level, then another one, and inside we have our new instance of our pipe, and we're just checking our tests inside it. So what we're actually going to do is copy this value, and we're going to say it should use the default extension when it's not supplied. So we're not actually going to change anything for this test because we're actually expecting it to always use megabytes. However, in this particular test, we're more interested in the fact that the numbers are being parsed out correctly rather than the extensions. So we can leave that one as it is. And what we're going to do in this one is actually override that extension. So as we looked at in the pipes as providers video, in the pipe section of this course, we then called our transform method with a second argument. So I'm going to call this one myExt. So this will actually change the extension. So I want to make sure that this MB on the end actually gets changed to the myExt. Similarly, what we're going to do is the same thing down here, and we'll say another ext. We can copy the value and paste it in at the end. So as you can see, we're actually just testing the transform method, which is a plain JavaScript class function, to make sure that our tests are running correctly. Now, if I save that out, we can open up the terminal, and you can see that we have our isolate file size pipe test. We have 3 ticks to make sure that our bytes are converted to megabytes. We're checking that the default extension is being used when we're not actually supplying one. However, when we supply a default extension, we're using myExt, which gets added on the end. Similarly, with the another ext, it gets added on the end. In the previous video, we looked at creating a pipe unit test, which we call an isolate test, because we are not actually importing anything that's relevant to the Angular testing framework. Now, our file size pipe allows us to boot up a unit test without importing anything from Angular and the testing framework. So what we need to do in this lesson is learn how to instantiate our file size pipe inside a component, and what we can actually do is test that this works correctly inside the component. Now, you don't have to do this, but if you're using many pipes, this may be something that you wish to adopt. So instead of just having our describe and an isolate test, what we're going to do is add another describe, and this is going to be our shallow file size pipe test. And in this video, we're going to dive a lot deeper into the actual testing pieces of the Angular framework. So now we have our describe block set up, we need to actually go ahead and import a few things from the top of our file. So the first thing that we're going to import is something called the test bed, which you may have seen before. This comes from the Angular/core/testing. So you can see that we actually use /testing rather than just core. So the testing gives us the testing framework or pieces of the framework that we need to go ahead and write our unit test. The next thing that we'll import is something called the browser dynamic testing module. Finally, we're going to import something called the platform browser dynamic testing. So these two essentially go hand in hand, and we grab those from the Angular platform browser dynamic /testing. We'll just hide the sidebar so we can see this full path. So we need to essentially use a few of these together to go ahead and actually create our test bed, which allows us to invoke things such as modules and also create components to test against. So the first thing that we'll need to do is go ahead and use this test bed, and we want to actually create an init test environment. So you can see here it says initialize the environment for testing. So what we need to do is actually pass in our browser dynamic testing module, followed by the platform browser dynamic testing. Now we actually need to call this as a function, similarly to how we would when we actually bootstrap an Angular application. We actually invoke the platform browser dynamic. However, in this case, we're invoking the testing side. So these are basically how to instantiate and create the test bed needed for our Angular testing. Now, I mentioned that we are going to actually test against a component. So what I'm going to do is add component, and we're going to generate a new component here. So we're going to create a template, and we're going to use some backticks real quick. And we're going to say that the size is then going to be an expression. We're going to pass in a size, and we're also going to create our file size pipe with a suffix that we can go ahead and create on this component's class. Now what we can do is quickly do class and test component. So it may be in some cases that you want to actually go ahead and create some kind of testing component, and we can create a property called the suffix. This is going to have no initial value, so we can use an undefined value if we want, which means that we get the default extension. We're also going to create an initial size, which is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we need to go ahead and import this component, which is undefined currently, from the Angular core. So above here, we can do import the component, which we are very used to by now from the Angular core. So this essentially allows us to create a component on the fly. So we're going to do this because we are going to essentially check the actual parsed out content of this component. So creating a component here on the fly just simply allows us to do this. The next thing that we need to do is actually create a few variables based on our component. So then we can go ahead and configure our test bed to actually configure the module that we want to test for this specific video. So what we'll do to begin with is create let component, and that's going to be of type test component, which is the class that we just created. And we also can create something called a fixture. Now this is going to be of type component fixture, which we'll import momentarily. Now it has a generic type of the test component. So this will essentially relate the test component with the component fixture. Now the component fixture holds information about our mounted component, and we can also use it to detect changes, access things like a debug element, which we'll cover, as well as accessing the native element, which we've looked at the beginning of this course when we looked at things like advanced components and the directives. So let's go ahead and import this component fixture. We need to grab this next to our test bed, so we can just simply import that from the Angular core /testing. So the next thing that we can set up is the element. So we'll do let L, and that's going to be of type HTML element. Now the reason that we are doing this up here is because we're going to create what we call a before each. Now the before each will actually get called before each test in our describe block, such as this it and this it. So when we create further tests inside of here, we're going to actually configure our testing module to dynamically create our component with our file size pipe. And we simply use these variables up here to access the particular things that we are binding them to inside the before each. So to actually get our test bed up and running, we need to call this method called configure testing module. Now this is very similar to an Angular ng module. We have things like declarations. So we need to provide a declarations array, which is going to contain our file size pipe. It's also going to hold our test component. So this is very much like an ng module, and it essentially allows us to dynamically create a very small module that we want to just test a few specific things against. So once this is actually all done, what we can do is start overriding the variables above the component, the fixture, and the element after this before each. So we get a new instance and we can assign a new value to them in this before each block. Now most of this is configuration, and we won't have to do this for every single test. So here I'm going to call this create component function because we want to create our test component. So we're simply assigning that to the fixture. Then to access this raw component, what we're going to do is assign it to the fixture.component instance. Now the component instance is very similar to the advanced components chapter where we looked at things like dynamic components and we accessed the instance of a dynamic component. So next up, we need to override the element variable, and we're going to just get a reference here to the native element. So we've got three different things. We've got the component, the fixture, and the element, and we're overriding here the fixture and the component as well as the element just so we can use these throughout our tests. So the hard part is out of the way. We have created our before each block. So let's go ahead and start writing some tests. We're going to start with it and should convert bytes to megabytes. Now we've already written tests similar to these. We're actually going to reproduce these. So we have it should convert bytes to megabytes is the same as above. And we'll do the same with the other two. However, we're going to use this more integrated approach by actually using a real component. Now with many unit tests, what we need to do to actually kick things off is call this method called detect changes. Now this will actually call things like ng on init, as well as other events and internal workings that kick things off. So we need to call this fixture and detect changes, and then we can go ahead and start writing our test. So at this point we can do the expect. Now what we actually want to reference is this element up here, which corresponds to the native element. So before we go ahead and actually start writing our tests, what we're going to do is actually log out the element, and then we're going to run those tests in the terminal. So here I'm going to run yarn test, and we'll wait for things to kick off so we can actually see what this console log is giving us. So all of my tests have now passed. However, because we haven't actually expected anything in this test, it will just pass by default. However, we are interested in this console log here. So you can see we have this div with an ID root, and we have a size of 117.74 megabytes. So what we're looking at is the actual compiled output in the DOM of our component. So this is actually parsing out our pipe, which is a component that we actually set up above where we have size. So at this point, what we actually want to do, and we can close the terminal for now, is actually check against our element's text content. So to do this, we can expect, and we can do el.text content. So this is similar to the inner HTML property. Now we could use to-be, however, it doesn't take into account things like white space and new lines. So what we're going to use is to contain, and then we're going to use size 117.74 MB, which was what we just saw in the terminal. So we'll save this out and check in the terminal, and you can see that we now have our tests that are passing. If we change this to 75, we'll actually see the test fail. So you can see here that it says expected this to contain size 0.75. So at this point, we've actually written a test that passes based on our shallow test. Now what we're going to do is a few extra things. So because we have access to the component, which is the component instance, what we can do is quickly log this out to see what it gives us. And then we're going to go ahead and actually use it. So we can open up the terminal. We can wait for things to recompile. All the tests have now passed. So we can see we have this test component with a public property called size, which then corresponds to the size that we created up here. So what we can do is actually override this in a test, much like we did with dynamic component inputs. So we're going to do component size equals 10.29.281. Now because we have made a change, we can call the detect changes again, and we can write another expect the element.text content to contain, and that's going to contain the size, and I've already calculated this one, it's 0.98 megabytes, so we can save that out, we can wait for our tests to recompile, and you can see that all of our tests are now passing. We can go ahead and finish these tests off, so we're going to duplicate this, and we can go ahead and take the actual text from this one. We'll add it into our new tests. Now what we want to do in this one is simply leave it as it was, so we can just remove all of this stuff. We're making sure that this is in fact ending with megabytes. And again, we can copy this and give it a paste in below. What we want to do is obviously copy the name of the test. So we can take this one here, scroll up to our other test, and we're going to provide the new value. Now what we're going to do in this particular test is actually change something on this component. So we can do component.suffix equals myExt. So in this case, you can see here we have comma and then myExt. So this is actually passing in a custom extension. So we're actually expecting something like this. If we go back to our test, what we can do is just simply add this in, and we can do myExt. We'll save this out and open up our terminal quickly just to make sure that everything is working. And you can see here that we have all 6 tests that are now passing. So in this lesson, what we'll do is a quick recap of what we've done. We've imported the test bed, the browser dynamic testing module, the platform browser dynamic testing. What we've then done is initialize our test environment with the first argument of the browser dynamic testing module. The second argument is the platform, which in our case is the platform browser dynamic testing. We then went ahead and created a fake virtual component, which is just used for this test on its own. We then create a size, which we are binding via our component. We then have our file size pipe. We provide it a quick suffix, which is initially undefined. We then set up some placeholders that we want to access, things like our component, the testing fixture, which gives us nice methods such as the native element, as well as the component instance, and allows us to call detect changes. And we're also keeping a reference to the native HTML element. And the way that we do this, inside our before each, we configure that testing module, which is essentially just an ng module for testing purposes. We add those declarations. We import the file size pipe, as well as our test component. What we then do is fixture equals the test bed, and we actually go and create this test component. We then get the value returned to the fixture, which is our component fixture type in here, which means that we can go ahead and create some new variables such as the component instance and the actual native element. And inside our tests, what we did was go ahead and start using things like text content, which is just a plain JavaScript API for accessing methods on the native element. We then added some properties and changed some properties on our dynamic component instances. And when we made those changes, we called the fixture .detect changes and adjusted our tests accordingly. In this testing lesson, we're going to learn how to test a service that we actually created earlier on in this course, the stock inventory service. Now there's a few things happening here, and we're using this particular service as a great example because we're actually testing a service with a dependency. Now we're using the HTTP dependency, and inside some of our methods on our class, we're actually using this HTTP, and we're using a get method, and we're actually returning that response to JSON. So what we're going to do in this lesson is learn how to test a service with a particular dependency. And the same approach applies when you have multiple or zero dependencies. Zero dependencies will make these tests a little bit thinner. However, most of the time we're going to be using some form of dependency. Now inside the spec file, I've actually set up a few defaults that we've already covered. We've got the test bed, the browser dynamic testing module, the platform browser dynamic testing. We're invoking that to then go ahead and initialize our testing environment. We've also got a describe and a before each that are all been set up. Now we don't actually have to create this test bed, initialize the testing environment in every single file. I'm only doing this because in my sidebar you can see that each video is actually its own specific small application. And in this video, we're just testing the service. So when you're actually creating these elsewhere, you'll typically only need to do this once. So let's go ahead and import our stock inventory service. And we get that from the current directory and the stock inventory service. So the next piece, we want to go into our before each and generate a new test bed. And in this video, we're going to do something slightly different. We're actually going to use the returned value of this testbed. So we're going to do testbed.configure the testing module. And inside of here, what we're going to do is create the providers array. And we're going to use the providers array because we want to pass our stock inventory service in. Now, when we actually go ahead and start using things like HTTP, we don't actually want to inject the real HTTP. We want to create a fake class that mocks the HTTP service. So what we're going to do is create a class which is essentially going to mock the HTTP. It's going to have a get method on there, which is simply going to return an observable response. Now, what I like to do is actually wrap things like this in a function. So we'll do create response, and that's just going to initialize this with an empty array. So let's go ahead and create this response function. So what we'll do is function and create response. It's going to take the body of what the response is going to be. And for this, we're going to simply just wrap this in an observable. So we're going to do observable.of. However, what we're going to do is use some of Angular's internal APIs, the new response and response options. So we can do new response is then going to contain new response options. And what we can simply do in there is pass an object with the body, which is going to contain a nice stringified version of the body argument that we pass in up here. Now, obviously, we need to go ahead and start importing a few of these just to make them actually work. So we'll import the observable from RxJS /observable. Now, because we are using of, we need to import from RxJS /add/observable /of. So that will then add that observable operator onto the observable. Then we also need to go ahead and import this response. Now, these actually come from Angular's HTTP. So we can do import the response. We also need the response options, and we can grab those from the Angular HTTP. So everything is being type checked, it's working correctly. So now we've actually created some kind of response. This is just a helper function that actually wraps things in an observable and then uses Angular's APIs to actually return us a nice response with the body of the data that we passed in. Now, we don't actually have any data yet that we're going to pass in. So what we're going to do is quickly set these up. So we can say const cart items is going to be an array. Now we can simply create these as product_ID. We'll give this 1. We'll say quantity is going to be 10. The second object is going to have a product ID of 2 and a quantity of 5. So that finishes off this particular response. So we're actually mocking the response here. We're not using the real APIs. And we can do something similar for the product items that we want to test along with this service. So we can go ahead and give this an ID of 1. Price is going to be 10. We'll give this a name of test. We can go ahead and do the exact same thing for another object. So we'll do the ID is 2. Price is going to be 100. And the name is going to be another test. So that just finishes off our fake response items that we're going to use them with our mock HTTP to essentially mock out the responses to using our service. Now, we've done this in this logical order because we actually need to do something with this providers, and that's actually pass in a custom provider for the HTTP. Now, if we go ahead and do provide HTTP, what we want to actually do is override this HTTP object, which we can go ahead quickly and import from Angular's HTTP module. So we want to override it with our own mock HTTP for the purposes of testing, which means that inside our stock inventory service, the HTTP that we're actually going to get is our mocked HTTP. So this will make more sense as we continue. What we need to do to override it is call a use class, and we want to use that mock HTTP that we just created above up here. So we're essentially saying use the token of HTTP. However, the value of that is the class that we've just set up. Now we're doing this because inside our stock inventory service, if we take a quick look, when we actually call this.http.get, we actually want to hijack that and return our fake data. And the way that we can do this is by actually latching onto the HTTP, which is returned from our constant of bed. Now what we'll do before we continue any further is quickly set up some variables like we did before. We're going to create a variable for the reference of our service as well as the HTTP object. Now inside our before each, what we want to do is simply override these. So we're just simply going to do HTTP equals the bed.get. So this will actually go and fetch that HTTP token and assign it to the value of HTTP. So we're going to use that to spy on these methods to make sure that they're getting called. Similarly, we can do something with the service. We'll do bed.get, and we want to go and get that stock inventory service. So there's a little bit of configuration that we need to do before most of our tests. However, once they're all set up, things are actually pretty easy to get going. So again, we can go ahead and create an it function, and we're going to say it should get the cart items because that's what our get cart items is doing. So we're going to test that method first. Now inside of here, what we want to actually do is use something called a spy on, and we want to spy on our HTTP. And the method that we want to spy on is actually the get method. Now at this point, we want to use the and return value, and we want to actually return the value of the cart items, but we actually want to wrap them inside our create response. So we'll go down and actually implement this. We can say create response, and we can just pass in our cart items. Now it may be that your data, such as cart items, actually gets manipulated elsewhere in the test. To overcome this, because it's an array, we can just use a spread operator and just copy that value into a new array. So any mutations that we do make or you may make in future tests don't actually affect the other tests that we're writing. So now we're all set up, we can use the service, and you can see we have these two methods available, get cart items and products. So we're simply going to use this one here. Now on the next line, we simply want to subscribe to that, and we're going to get the result through these function arguments. Now inside here, what we're going to do is simply log out the result, and we'll check this out as we run the tests. So we'll open up the terminal, wait for things to recompile, and you can see that it says that we have passed the test, even though we haven't technically written one yet. But you can see that we're actually getting this fake response object that's being passed through to us. Now, if we scroll up, you can see that we have the product ID of 1, quantity 10, product ID of 2, and quantity of 5. So everything is being passed through our fake HTTP for us. Now, what we need to do inside of here is actually write our expect block. So we can say we're going to expect the result.length to be of 2. And we're going to also say expect the result to equal the cart items. What we also want to do is go ahead and duplicate this because we're going to create a similar test for our products. So we can change this over to get the product items. Now there's a few things that we need to change inside of here. Instead of the cart items, we actually want to change this to the product items. So we're actually using that HTTP get, and we're essentially returning our own mocked value that we created above. Now instead of get cart items, what we want to call is the get products method, and then we want to make sure that this matches our product items. So we'll save this out, and we can check in the terminal when these actually compile that everything is passing correctly. So what we'll do is close the terminal, and we'll do a quick recap of what we covered in this video. So from the top, we have imported the test bed, and we configured the environment. We've then imported our service. We've then created a create response function, a mock HTTP class. We've then created some static data to mock out our backend APIs. Inside of the before each, we have configured our testing module. We've provided our service. However, for the HTTP, because the HTTP is a dependency of the service, we're using that class. We're overriding the value of the HTTP with our own mock HTTP. We're then getting a reference from the testbed to go and get that HTTP value so we can spy on things and provide the mock data. We also grab a reference to our service. And inside the actual test, we're using a spy on the HTTP GET. Now, obviously, you can use the exact same thing for GET, POST, PUT, and DELETE methods. However, this is demonstrating the concepts on how to do this. We're then returning a value, which simply creates that response for us. And inside the body of each of our tests, we're calling those service methods, and we're calling the subscribe block. We're getting that result. And inside the subscribe, we're then writing our testing logic, such as expecting the result to be a length of 2. Similarly, inside the get products, we're doing something very similar with a different data set. In this video, we're going to learn how to test our counter component that we created earlier on in this course. Now, the counter component has a few methods on it that we want to test. We want to test the increment and the decrement, and the logic that we actually want to test against is whether it's passing our checks that we've added of whether it goes above or below particular values when we're incrementing and decrementing. So for this, I've actually created the base of what we need for our test file. We've got the component fixture, the test bed, all the testing modules that we need. I've initialized the test bed, and we've imported our stock counter component. Inside the before each, we are then registering that component as a stock counter component as part of the declarations array. So we can go ahead and start writing our tests. So what we're going to do is a let component, and that's going to be of type stock counter component. We're then going to create another variable to our fixture, which is then going to be of a generic type of stock counter component. So those are the only two that we're going to use in this video, and we're going to override them inside our before each. So the first one we're going to do is the fixture, and that is going to be the result of our testbed.create component. We then need to pass in our stock counter component. Secondly, we're going to do component equals the fixture.component instance. So we're going to be using this component to actually increment and decrement the values in these particular tests. Now, because this is a dynamic component in some way, we're going to actually set a default value. So we're going to initialize that with a value of 0. So the components are really easy to test in this case. So what we can do is it should increment correctly. This is also just a function. Now inside of here, we just need to call component.increment. And what we can do is expect the component.value to be 1. So we'll save that and open up our terminal. We'll just run that yarn test again, just to kick things off. We can wait for Webpack to compile everything. And you can see that we have this should increment correctly. So components are very easy to test when we're actually just testing the methods on the components. So what we can do is just duplicate one of these. And this time we're actually going to check whether something decrements correctly. So what we're going to do is simply add another line to this. So we're going to increment it first off, and then we're going to go ahead and decrement it. So we should expect that value to come back down to 0. So we'll save this and wait for everything to recompile. And you can see here that we have the component's value is of 0. Now we can actually jump through to our component, and the value is actually kept internally to the component. So this is the value that we're actually checking against when we call the increment, because this dot value then gets incremented with the step, or it gets decremented depending on the method that we actually call. So let's go ahead and write some more tests for our component. What we're going to do is actually copy this one because we want to make sure that it doesn't actually go below the value that we set as the minimum. So we can do it should not decrement below the minimum value. And we can leave these as they are. We can say we're going to increment this one. We're going to then decrement after. However, when we call decrement again, we should still expect that value to be 0 because that's the default value as the minimum inside our component. We can also check the same with our maximum values. So what we can do is go ahead and just duplicate this one. We can change this to increment over the maximum value. Now, instead of incrementing and then decrementing, what we're going to do is write a quick loop inside of here and then call this increment function. So we can just do for let I equals 0. Then what we're going to do is less than 200, and then just increment that count. So we're going to go ahead and increment this function 200 times inside our loop. Now we're going to do this because we want to make sure that our maximum value of 100 is actually hit. So we can go into our component and actually check that we have a maximum of 100. So no matter how many times we actually increment, it should always stop at 100. So we can actually remove these and just save this out. We'll open up the terminal as we save these out. So we should have our 4 tests that are passing. The one from decrement, which doesn't go below the minimum value, and it won't increment above the maximum value. So you can see here in the actual terminal, we've got our 4 tests, which are all passing. So in this video, we have learned how to configure a testing module. We've set up our component. We've set up a fixture, which takes our stock counter component. We've added our stock counter component to our config testing module. We've overwritten these variables in our before each. We've given it initial value of 0. If we wanted to keep going with this, we could override the steps, the minimum maximum values, and actually write more tests just to make sure that everything's working perfectly. We've then added an increment test. We've then added a decrement test just to make sure things are working. And we've then made sure that we do not go below or above those values that we specified inside the component. In this testing lesson, we're going to learn how to test the inputs and the outputs of a component. So here we have 3 inputs. We have a step, which tells the component what step to increment our counter in. So for instance, if we use 10, our counter would be incremented in steps of 10. We also have a minimum value, and we also have a maximum value. We also have an output, which is an event emitter, which also emits the number of what was changed. So we can dive across into our test. Now inside of here, what we can do is just expand on the previous video. What we're going to do is create a test, and we can say it should not increment over the maximum value. Now what we're going to do inside of here, because we have access to our component, which is a component instance, we can just reference these properties which we have available here. So we have value, step, min, max, and increment, focused, decrement, and changed. So the first one that we'll test is the step, and we're going to say that that's going to increment in steps of 20. We're also going to say that the component has a maximum value of 20. So what we can do now is increment that, and we're going to actually increment it again just to make sure that this is in fact working. Now inside the expect, what we can do is reference the component.value, and because we have a maximum of 20, we can then say we want that to be 20. So this is how we can actually test an input. So we'll save that out and we'll let that recompile. And you can see that we have here, it should not increment over the maximum value. So this test is working, it's passing correctly, and our logic inside the component is working as intended. So this is how we can actually test an input to a component. The step is an input, the maximum is an input. We can call that public increment method, and then we can just check that everything is then okay. Now the next thing that we're going to test is whether it should call the output on a value change. Now to do this, we are going to simply subscribe to our component inside the body of our function. So the next thing that we can do is a spy on. Now what we want to spy on is the component.change property. However, the method that we want to spy on is called emit. Now to actually do this, we can call the function called callthrough. And if we open up the counter component, we can actually see that we have this change property. However, because we're binding a new instance of the event emitter, it actually has a new emit property. So we're just making sure that this is in fact being called. Now the way that we can actually test this is by testing the result of the output. Now the way that I'm going to do this is set the step of the component to 100, and then I'm going to simply call component.increment. So this will actually make the component jump from a value of 0 to a value of 100. So now we can go ahead and expect the component.changed.emit and we can use to have been called with. So if we go ahead and say it's going to be called with 10, if we open up our terminal, we can actually see that this test fails, but the actual calls were 100. So we can go ahead and change that to 100. We can scroll down and wait for everything to recompile, and all of the tests are now passing. We are successfully testing that the emit has been called with a value of 100, because that is what's going to get called when we actually emit something via a decrement or an increment method. In our case, we are incrementing, so we're actually checking that this emit has been called with a value of 100 because we are actually adding the step to the value, which is when we change the step to 100. So in this lesson, we have focused on inputs and outputs. We're adding some dynamic input values, we're incrementing, and we're incrementing twice just to make sure that we aren't actually going over that maximum value that we specified. We're setting up a spy on here, so we're spying on the component.change property, and we're checking that the emit function then gets called. When it does get called, we're then using that spy to make sure that it's been called with a value of 100, because our step is saying it must be in increments of 100. In this testing lesson, we're going to learn how to test the user interaction in our template. So here I have a button with a plus inside, and this goes ahead and increments the value. We also have the minus, which decrements the value. Now these are both sibling elements. We have a button next to a button, which makes things a little bit easier when we want to go ahead and test the interaction between our templates. So what we need to do is a little bit different to what we've been doing so far. We've been using a lot of plain JavaScript methods and testing things on our component class. However, for this example, what we're going to do is something slightly different and actually query the DOM elements and then trigger some events. So you may wish to do this in your testing, or you may wish to just stick with things like testing the inputs and the outputs directly, as well as the methods on the component itself. So we're going to take this one step further in this video and learn how to test the interaction via the user with our templates. Now everything inside of here is pretty much the same. We've got our component, the fixture, the before each, which creates our module with our counter component. We also create this component. We grab a reference to the fixture, the component instance, and we also set that initial value to 0. So what we're going to create is a new variable, which is going to be of type debug element. Now we haven't covered this so far, so what we need to do is actually go ahead and import this. Now this actually comes from the Angular core, so we need to import this from somewhere slightly different. Now if we go ahead and actually click through to this, we can see that the debug element also contains a few properties that we might want to use. In our case, what we're going to be using is this query, so we can actually go ahead and query some nodes, and we're also going to be use that trigger event handler. So what we need to do inside the before each is we can override this with the fixture.debug element. So this is something else that our fixture is actually providing for us. Now inside the test is where things differ from what we've done so far with the components. So we're going to say it should increment when the plus button is clicked. So we're going to work out how to actually test that interaction. Now at the moment, we're actually overriding this L with the debug element. And I mentioned that query. So we can do L.query. And what we can do is use something called the by.css. Now this is very similar to something like a query selector, where we'd do something like .class. In our case, what we actually want to get is the button, and I'm just going to use the first child because that is the first button next to our second button. You can see that the by is actually undefined, so we need to go up and import this, and we actually get this from the Angular/platform browser. So if we go ahead and click through to this, you can see that we can actually use this class to match particular elements. So here we have an all method, which matches all the elements, and we have a CSS, which matches elements based on the given CSS selector. So this is actually quite nice, and we also have the ability to query by a directive name. So what we're going to do inside of our first test is we can say that we want to query by CSS, and we're going to go and grab that first button. Now what we're going to do is simply call the trigger event handler. Now this is basically using that debug element that we looked at to call this trigger event handler. So this is simply just chaining those events. Now what we want to do is in fact click it, and the second argument, if we go ahead and actually click through, we can say that we want to pass in an event object. However, what we don't want to do in this case is pass an event object, so we're simply going to pass in null. Now at this point in our test, what we're going to do is call that fixture.detectChanges, and then underneath we can say expect my component.value to be the value of 1. So I can go ahead and save this out, and we'll open up the terminal, and you can see that we have a passing test. It says this should increment when the plus button is clicked. However, there's one thing that we aren't testing here, and that's if we open up the counter itself, we're actually logging out this value here. So at this point, we're actually going to test whether this value has changed in our template. Now again, this is really easy, so we can do expect the elements.query, and again, what we're going to do is use by.css, and we're simply going to grab the p tag. Now inside the component, you can see that we don't have any other p tags apart from this one, which means that our test is pretty safe. In a better example, you may actually add a class such as .value and then assign that to the p tag. For our example, we're just going to leave this as p. Now what we can do is expect this to be 1. Now it needs to be a string. However, we need to actually get access, which is also provided to us, and we can do native elements. So what we need to do is chain this again and do .native element. Now this time, because it is a paragraph tag, we can just look at the text content. So if we save this and open up the terminal, so here we have confirmed that we have in fact incremented the value. The value is then 1, and as a result, our p tag has then been updated. So what we're going to do is close this off. Now instead of actually creating these for every single test case, what we're going to do is then focus on how we can test a keyboard event. So what I'm going to do is below here, we can do it should increment the value when the up arrow is pressed. Now we can't actually test these directly, so what we actually need to do is create a new event object. Now for this, what we're going to do is const and then event equals a new event, and we're going to specify keyboard event as the type that we want, and we can just say as any. Now we're doing this because we want to do event.code and then give that the value of arrow up. Now we're doing this if we check inside our component, because we actually can control these via our keyboard events. Here we have the on key up. Now if we jump down into the handler for this, we have arrow down and arrow up. And then if those actually exist in our object, we're simply going to call this .increment or decrement based on which event code was passed through. So this is simply what we're mocking out here with the event code. We're saying it's going to be arrow up, which then goes ahead inside our handler and calls a particular function for us. Now the way that we can access it is simply traversing the DOM. So at this point we can do l.query, we can say by.css, now we can do .stock-counter, and we want to go for the first div, and again the first div. And all we're going to do is call a trigger event handler. However, we want to pass the key down event into this. Now we're doing the key down because inside our counter component, we're actually listening to the key down. If we can see this inside our template. So all we're doing is simply triggering that event. Now, instead of passing in null here, what we actually want to pass through is our event. So this is essentially creating our own custom event, and we're simply passing it into the triggered event handler. Now at this point, we can call the fixture.detectChanges, and we can finally write our expect the component.value, which is the value that's being displayed in the DOM, and we can say that we want that to be 1. So we'll save this out and we'll open up our terminal, we'll wait for that to recompile, and we'll see that the result of the test has now passed. So in this lesson, we have covered a few things. We'll go up to the top and do a quick recap. We're testing component templates in this lesson. So we're importing something called by. We're using the debug element. We're creating a before each. We're configuring our test module. We're assigning the debug element because we want to use these particular query methods and trigger event handlers. Inside our first test, what we're doing is querying this button by the first child. We can obviously expand these to create more tests. However, the code in them is identical, just testing different things. We're then triggering an event handler with no particular event object because we don't actually need anything through the function arguments of the event. We're then detecting changes. We're grabbing that component value, and we're also testing the result of that update in the DOM. And we're expecting that to then be a string of the value of 1. Similarly, we are testing an interaction via the user's keyboard events. We're creating our new event object. We're assigning it a static code with the value of arrow up. We then reference our particular div, which is listening to that event. We then trigger a key down event and pass our event object that we created up here into that event handler. We're then calling the fixture.detectChanges, and we're expecting that component value to then be 1, because for each of these tests, the component's value is 0 because this is inside before each. So each of our tests are being ran with a new instance of our component. In this testing lesson, what we're going to learn how to test is what we call a container component. So you can see inside of here, I have my containers and I also have my generic components. Now this component that we want to test was actually our stock inventory component. That was part of the reactive forms chapter that we did. So inside of here, this should look pretty familiar, which we covered earlier on in this course. We have our components that are being rendered out inside our container component. Now the things that we're interested in testing are these particular items, and we're going to learn how to test the stock service. So the main focus for this video is testing a component with an asynchronous provider. And the asynchronous piece in this case are our cart and our products, and how we merge them, and how we're using the observable along with fork join to pass the cart and the products into the observable to join them so that in the subscribe we can get both of them resolved at the same time. Now inside this subscribe we have a few things going on. We're creating a new map. We then iterate over a few things and we pass that map info into our map. So we're going to learn how to test these particular things and focus on the asynchronous part of the service. Now inside the actual testing file, I've got a few things imported. However, we'll walk through these as we add them to our testing setup. Everything else up here is pretty much the same. We have a component fixture, the test bed, the modules, as well as the debug element. Now, because our form is using the reactive forms module, we're going to have to use this inside our testing module. Similarly, we're going to import all of the components that are actually used inside our stock inventory template. So inside of here, you can see that we have stock branch, stock selector, and the stock products. And some of these components use other components such as the counter. So we're importing these for a particular reason. If we jump down into our testing module, so we can import the reactive forms module, the next thing that we need to do is add our components to this array. So the first one that we want to add is the container. It's the stock inventory component. Then we want to add the stock branch component. Then we want to add the stock counter component. Then we want to add the stock products component. And we also want to add the stock selector component. So we have 1, 2, 3, 4, 5 components. And above we have 1, 2, 3, 4, 5, followed by our stock inventory service. So I'm going to copy this value and we can go down into our module and we can say providers is going to be the stock inventory service. However, again, what we're going to need to do is actually override this with our own mock. So we're going to do provide, and the value is going to be the mock stock inventory service. So we need to go ahead and basically implement our own mock again. So we can scroll up, and outside of here, what we can do is a class. And what we're going to do is create those get products. And we're also going to create the get cart items. Now, if we go ahead and click through to the service, what we actually have is the get cart items. This returns an observable, and the get products, which also returns an observable of each product. So we're going to go ahead and just mimic this inside the response. So we can just do return observable.of, and we're just going to pass in an array of data. So we're going to say that the ID is going to be 1, price is going to be 10, the name of this one is going to be test. The second object, what we can do is the ID of 2, the price is going to be 100, and the name is going to be another test. So here we're just simply mocking out that data. We don't have the observable of just yet. So what we can do in a moment is just import that. We'll duplicate this, and we'll go ahead and change some of these properties inside our second object. So what we want to do is create the product underscore ID. It's going to have a value of 1. The quantity is going to be 10. Now for the second object, what we're going to do is just create another item. So we'll say the product ID for this one's going to be 2, and the quantity is going to be 5. Now to finish this off, we can go ahead and import the observable, and we can get that from the rxjs/observable. We also need the of, so we can import the rxjs/add/observable/of. So all of our red lines have gone away. We are successfully importing both of these. So now inside our inventory service, we're actually going to be using the class of our mock. Now we actually want to use this service. So above here, what we're going to do is just do let service, and that is then going to be of type stock inventory service. And then inside our before each, what we're going to do is just override that with the value that we want. So we can do service equals the element dot injector dot get, and we're going to ask for the stock inventory service. Now this is because the stock inventory itself is injected into our component, which means that our debug element can essentially go and get that via the injector. So all this is really doing inside the stock inventory component is actually making sure that we are going ahead and fetching this so we can go and reference it in our tests. So now we're all set up. What we can do is start writing some tests. So we're going to say it should get the cart items and products on init. Now inside the body of this test, what we're going to do is create a few spies. So we can do spy on, and we're going to spy on our service, and the method is going to be the get products. And what we'll do is make sure that those are called, and we can call through. We can duplicate this, and we'll change this one over to the get cart items. So we're actually making sure that we're calling both of these functions. The next thing that we want to do, because these live inside the onInit, is we can call the component ngOnInit. So this will actually kick off the lifecycle hook for our component. So after this has actually completed, we can then go ahead and write our test. So we can expect the service.getProducts to have been called, and we can duplicate this, and we can say the get cart items has been called. Now this is a very basic test. So what we can do is it should create a product map from the service response. Now we're doing this because inside our stock inventory component, if we click through to this, we can see that we're actually adding items to our product map. So at this point, what we can actually verify is that our test items are being added correctly, which means that our logic here is working as intended. So down below in our test, all we need to do is expect the component.products map. Now what we can do, if you can recall, we actually use something like a get, and we passed in the product ID in the reactive forms chapter, and that just takes a value, which is a number. So we can just say that I want to get the value of whatever is sitting under the key of 1, and we want that to equal an object with an ID of 1 and a price of 10, and the name is going to be test. So if we quickly scroll up to the top, we can actually see that this static value inside of here. So we have ID 1, price 10, and the name is test. So down inside of here, we're simply just verifying that that is what's coming back. So this is actually verifying that our products map is adding them correctly. We can change this one to 2. We can change this one to 2. We can change the price to 100. And we can say that this is going to be another, and just change the T to lowercase to actually match the fake response that we have added inside of here. Now we haven't actually ran any tests yet. So what we're going to do is yarn test. So while that's compiling, what we're going to do next is actually check that the products has been maintained on the actual component. So both of our tests so far have successfully passed. Now what we want to do is it should store the products, response, then inside the body of the function, we're just simply going to call that ng on init again. So we can do component ng on init to initialize those. Now inside of here, we want to check the component.products. Now just to verify what we're actually doing here, we can jump through to our component. We have this products array, which is being added inside the ng on init, which is based on all of the products that then come back. So that means that our test is actually going to have an array of our products that contains this. So what we can do for simplicity is just copy this value, and we're going to use it in the expect inside our test below. So what we're going to do is to equal, and we can just simply paste in those values to make sure that our test is actually equaling that array of products. Now we'll save this out while we open up the terminal just to make sure everything is working correctly. Now for the next test, what we're going to do is it should create a stock item for each cart item. Now this test is simply going to check whether our add stock function on our component is actually being called with the correct values. So before we go any further, and we can close the terminal for now, we'll jump into the stock component. And the method that we want to check is the add stock. So for each item in our cart, we're actually adding that programmatically to our reactive form. We have this add stock method, which we pass an object, and it gets passed into the create stock. It then returns us a new group with a product ID and the quantity. So what we want to do is make sure that that add stock function is getting called. So that means down in our test, what we want to do is create a spy. We can say that I want to test that my component, the add stock method, is being called. So what we can do is component and ng on init to kick things off, and we can say expect the component.addStock to have been called with. Now before we go any further, we can go up and actually copy those values, but the add stock function is going to be called with our product IDs. So these are the list of products, and we want to fetch those items from the cart. So up here we have a product ID and a quantity. I'm going to take both of these values because we're going to use them both in these tests. So I can paste the first one in, and we can take this argument here and paste it into our second one. And we're checking that our add stock function is being called the first time with a product ID of 1, quantity of 10, product ID of 2, and the quantity of 5. Now if we open up the terminal, we can wait for things to recompile, and we should see 4 passing tests for our stock inventory component, just to verify that everything in our container component is being set up properly to be consumed by our stateless components. So let's go ahead and do a quick recap of things we've covered. We're importing the usual suspects, the component fixture, the test bed, and the modules and the debug element. We're importing the reactive forms module and all of our components. We're then initializing the test bed. We've created a mock service, which returns an observable of each of our mocked values. Then inside the actual describe block, we're using our service, and we're overriding it with the service from the actual component itself. Inside our tests, what we're doing is making sure that these methods are being called. Then we're actually moving on to some more advanced tests where we're checking that our product map is storing those values that we asked it to correctly. Then we moved on to our products array. So the products list is actually storing all of our products that come back from the API. And one of the roles that our container component actually has is calling this add stock method to delegate down into more stateless components. So we're just making sure that these actually be called with the correct items. In this lesson, what we're actually going to cover is something not directly related to learning how to test, but a nice tip for when you are testing. So in the previous lesson, we actually covered testing our stock inventory component. Now you can see here that we have this whole list of component imports, and then we go ahead and we make sure that we're registering them inside our declarations. Now, depending on how you want to test, you can optionally remove all of these apart from the actual component that we want to test, which is our stock inventory component. Now, the reason that you may do this is because you may have a lot of components. So I'm going to just simply delete this, and I'm going to import something called the no errors schema. So what we can actually do with this is tell Angular's module that we are happy to accept the schemas of no errors schema. So what this will actually do in turn is allow us to use this particular component without worrying about the child components in the actual template. So here we have the stock selector, the stock products, and the stock branch, which if we didn't actually include this would throw an error on us. So what we'll do to confirm that this works, we can run a yarn test just to make sure that our no error schemas is in fact working. Now, depending on how you want to test, you may wish to use this. However, it may leave things a little bit more error prone. However, it can be a handy test if you just want to test a single component that may have child components that you don't care about because you may have tests for them elsewhere. So by using the no error schemas and adding it to a schemas property on the module, this allows us to essentially use the component without worrying about the child components. The other nice thing is that this is actually faster than compiling all of our components. So it may be nice to use this when you want to increase the speed of all of your unit tests. In this testing lesson, we are going to learn how to test an attribute directive. Now, we've already created our credit card directive earlier on in this course, so we're going to actually demonstrate how to use things like creating an event and actually getting the value and making sure that our directive is working properly. So this directive actually formats the numbers of a credit card. So when we type something in, such as 1, 2, 3, 4, 5, 6, 7, 8, what our directive will do is actually put the space in between them to actually format it for the user like a real credit card would. So if we jump into our spec file, what we actually have is imported the credit card directive, and everything else is pretty much the same as what we've already imported in other videos in this particular chapter. So we've got all of our imports, we're importing the buy function, we've set up our testbed environment, and here I have created another test component which we're going to build out. And inside of here, we're creating the same typical variables that we've been using in the other tests. So let's go ahead and get started. Now what we're going to get started with is this template, and we're going to create an input with a type of text. And what we're going to do is bind an initial value to this particular input, and we can just say that that value is called the value. Now we're also going to bind our credit-card to our input. So our directive is actually going to work on this particular input. Now we can say that the value is going to be 1, 2, 3, 4, 5, 6. So we're going to start it off with an incomplete card number and then actually test the actual output of this card number. So we're actually using this test component as a reference in here. So we're doing let component, and then we're also passing it as the generic type to the component fixture. So everything else is pretty much the same. We are overriding the fixture variable with the create component. The component is then referencing the component instance, and we're also getting the element access, which is our debug element, which allows us to use things like query. So let's go ahead and start writing the test for it. What we're going to call this one is it should format the string with spaces. Now inside the actual test, what we're going to do is something a little bit different, and it's a little bit more complex, which is why I wanted to show you this, of how to trigger potential events that you may be using or creating for Angular apps. So what we want to check is the value. So what I'm going to do is create a constant with the value of l.query. Now instead of using by and then CSS, which we've already used, we're actually going to use the directive. So what we can simply do is pass in the credit card directive. Now what we actually want to reference is the native element. So this gives us access of the native element that our directive has been queried. So this will essentially go in and look at our credit card directive and give us the access to the native element, which is the input. So back inside of our test, what we can do is go ahead and set the value of our directive to be something different. So we can say 475123. Now what we actually need to do at this point is dispatch a custom event. So this will act as if the user has actually typed something in to our input. Now we're not using two-way binding. So what we'll do is directive and then dispatch event. And then inside of here, we can just call new event. And the event that we want to dispatch is an input event. Now the reason for this is if we jump inside of here, our host listener is actually listening to an input event. And because we specified $event as the actual string value that we want the argument of the $event, we then get the event, which is of type keyboard event. We then do things like event.target, and we also access the event.target.value. So here we're just creating our own event object. Now at this point, what we can do is expect the directive.value. Now because this is a native element, this is technically just a plain DOM API at this point. So we can do things like dispatch event and we can reference the value. Now at this point, our value should be the 4751. However, it should have a space and it should be 2, 3. So what we can do is open up our terminal. We can run that yarn test, which will then kick off our tests. Now, the other thing that we're going to test underneath this is we're going to change the directive's value again. So we can say the directive value equals the 475123, and then we can go ahead and add some more numbers to actually complete this credit card. So here we've got 16 numbers. We've got 4, 8, 12, and 16. So at this point, what we can do is go ahead and dispatch another event, and we can then go ahead and check the value. So we can copy this value and paste it in below. Now I'm going to paste the entire string, and then we can go ahead and then separate these every 4 characters. So when we save this out, our test recompiles, and you can see that our test is passing. It should format the string with spaces. There's also one more thing that we could test. So what we'll do is just copy this and we'll create another test. So what we're going to do is it should have a max length of 16 characters. So what we're going to do in this test is actually create some more numbers, and we'll make sure that our input is actually working as intended. So we can save that out and we'll open up the terminal. So even though we are adding a number that's actually longer, our directive inside, if we jump through, is actually trimming these particular values. So we're removing the white space here and replacing it with nothing. Now, if the value's length that's actually returned from this replace is greater than 16, we're going to use the substring to actually just trim that string and limit it to the 16 digits.